In this clip, we will use pandas and NumPy to detect and treat outliers in the Titanic dataset. Here we are in the Jupyter notebook. Let's look at the age attribute first to see if we have outliers in this particular attribute. Here we are creating a histogram to check the distribution of age. We have also set the bins to 20. Let's execute the cell. Well, we have already seen this histogram before, but now let's see this from the outliers perspective. By looking at this histogram, we can say that while most of the age values are around 20 and 30, few age values are in the 70s and 80s. Let's try to explore those rows where the age is more than 70. Well, we have 6 rows in the result with one male passenger with the age of 80. Now let's explore another attribute, that is passenger fare. In the next line, we are creating a histogram for passenger fare. And in fact, there are few passengers who have paid exceptionally high fare than rest of others. Let's also create a box plot for passengers fare. In the box plot, cross marks outside the whiskers boundary suggest that we have outliers. This extreme outlier is in fact significantly far from others. Let's try to investigate what's going on here and if we can find something interesting. In the next cell, we are exploring rows where passenger fare is equal to maximum fare. Let's execute the cell. And here we have 4 passengers in the list. As you can see, all of these 4 passengers have paid a very high fare of 512. Moreover, they have a common ticket number. So it means that all 4 of them could be from the same family, or at least they were together. All of them were also traveling in the first class. So it may be possible that this family or the group of individuals booked their ticket at the last moment and had to pay a very high fare. And also, 3 of them survived the Titanic disaster because we have a value of 1 in the survived column. And for the 4th one, we don't have information because it is in the test dataset. We know it because if you remember, we had manually set the survived value to -888 for the test dataset. So what can you do about these extreme values? Well, we are not removing these entries as of now, but it was still worth exploring the extreme values. In fact, these extreme values often carry some very interesting insights. But also, because we know that we have a very skewed distribution of fare, we can apply some kind of transformation to make it less skewed. Transformation is a very common way to treat outliers, at least to some extent. As we know that the passenger's fare will never be negative, therefore, we can try the log transformation. In the next cell, we are applying the NumPy log function on the passenger's fare. Also, if you can see, we are adding 1 to the fare deliberately because few of the passenger fares are 0 and log of 0 is not defined. Finally, we are also storing the results of the log in a variable log fare. Let's execute the cell. Now let's create the histogram once again on the log fare. So if you look at this histogram, you can find that this is now a less skewed distribution. In fact, such transformations can be really handy at times. Binning, as I told you earlier, is also a very useful technique for outlier treatment. In pandas, you can use the cut or qcut function for binning. We are using the qcut function here that performs quintile-based binning. In the qcut function, we have passed the passenger fare and then we have specified 4 as the number of bins. So basically, we are splitting the passenger fare in 4 bins, where each bin contains almost equal number of observations. Let's execute the cell to know what is going on. So here, pandas has created 4 bins, and you can look at the range of each bin as well. Once the bins are created, pandas has assigned each observation into 1 bin. You can also specify names for each bins using the labels attribute of the qcut function. Here we have specified names for 4 bins ranging from very low to very high. You can use any names as per your wish. Now let's execute the cell. So now the pandas has assigned each observation 1 label. So basically we are converting a numerical feature to a categorical feature where each bin level is 1 category. For your reference, such techniques are also known as discretization techniques because we are creating discrete categories on continuous numerical features. Now let's create a quick visualization to depict number of observations in each bin. So as we have converted a numerical feature to a categorical feature, you can again use the value_counts method to get count per category. And then we are using the plot function and setting the plot type to be bar to create a bar plot. So here we can see that we have similar number of observations in each bin. So now we have seen how binning works. Let's create a new feature to store the bins that we have just created. We are storing the passenger fare bins in a new column and we have given it a name of fare_bin. We may also use this newly created feature in our modeling activity later. Let's execute this cell to create this feature. Well, in this clip, we have seen several methods to detect and treat outliers. Now we will move towards our next topic, that is feature engineering. Well, even though I have not formally introduced you to the feature engineering term, but we have already done some feature engineering work so far. If you recall, we have already used name attribute to create new title feature. Then we used the passenger fare attribute to create fare bin feature. So next we will further work on our Titanic dataset and we'll perform some more feature engineering. So let's explore the feature engineering in more formal way.